The first way that we can estimate a derivative of a function at a point from a table is from a table. And I'll tell you, if you're looking at this in terms of preparing for the AP exam, this kind of question right here actually comes up a lot in AP free response questions. They love to give you a free response question or two where they can just give you a table of values, because as we'll see throughout the course of this class, there are so many things that you can get from table of values. We've already talked about finding limits from a table. We'll talk about a lot of other things that happen from a table. And one of them is that we can at least estimate a derivative at a particular point. So let's consider the function f of x with values listed on the table below. And so all we're going to have for this function is this table of values. And so I'm going to give us several just so that we can kind of at least have a general idea of what's happening with this function. So the first point we're going to look at is negative 2, 6. And then we'll look at the point 0, 3. And then 3, negative 7. So if we look right now, it looks like we have a function that's kind of generally decreasing, at least based on these three snapshots off the table. It goes from 6 to 3 to negative 7. Now let's bring it back up. So let's look at 5, negative 1, 8, 2, 11, 6, and then the last point that we'll throw on is the point 13, 3. So we have a function that just kind of generally decreases and then somewhere maybe starts to increase back up, and then it looks like as we kind of make our way it starts to decrease again. So some function that fits those table values. Well, what I want to do is I want to estimate f prime of negative 1, in other words, the instantaneous rate of change at negative 1, and let's also do f prime of 7. And so all we can do, we don't have any other information about f of x. So let's say we don't have enough information to find f prime of x. I don't have, if you think back to that limit definition where I have to find what f of x plus h is, I don't have an f of x plus h laid out here in this table, and I don't have an f of x where I can go get it. So I don't have enough information to do the limit definition, but we do have enough information to at least approximate what it asked for, which was f prime of negative 1 and f prime of 7. And the way that we're going to do that is we're actually going to kind of go back to when we look at average rate of change over an interval, except to approximate the instantaneous rate of change, we're going to look at the smallest interval that we can get from the table. So we're going to go back to average rate of change, but we are going to try to keep the interval as small as we can. That's the best we can do to estimate the instantaneous rate of change from the table. So what we're going to be looking at is the smallest intervals around negative 1 and around 7. And we are going to go back to looking at the average rate of change of that interval and saying that it's an estimation for the instantaneous rate of change. So if I want to look at our f prime of negative 1, and because we're estimating, I'm going to use the approximately equal to sign. Well, if I look for negative 1 on the table here, the smallest interval, it's between negative 2 and 0, and so this right here is the smallest interval that I can use. So let's find the average rate of change over this interval and call it our estimate for f prime of negative 1. So this is going to be f of 0 minus f of negative 2 all over 0 minus negative 2. Well, f of 0 is 3, f of negative 2 is 6, that denominator is positive 2, and so this comes out to be negative 3/2. And so the best estimation that we have for f prime of negative 1 is negative 3/2. If you think back to what you already know about rate of change, the idea that it's negative for this value tells us that the function is decreasing, which is what we kind of see. We go from 6 to 3, so we can say, yeah, it kind of looks like the function is decreasing approximately at a rate of -3/2. So now let's figure out what f prime of 7 is. And the reason why I want to do 7, -1 happens to be the midpoint between -2 and 0. It doesn't have to be the midpoint of your interval. If I want to know f prime of 7, I'm still looking for the smallest interval around 7, which is going to occur between 5 and 8. So it doesn't matter that it's not the midpoint between 5 and 8. That's still the smallest interval I can get from the table, so that's what I've got to use. So f prime of 7 is going to be approximately equal to f of 8 minus f of 5 over 8 minus 5. Well, f of 8 is 2 minus f of 5, which is -1. And it's all over 8 minus 5, which is 3. And so if I look at this, that's going to be 3 over 3, which is 1. And so we can say the instantaneous rate of change around 7 is actually equal to 1. And if you look at what the function is doing, it goes from -1 to 2. It is, in fact, increasing, so it makes sense that we get a positive value for the instantaneous rate of change. So you can kind of start to make some connections, which is actually something that we do in Unit 5, but you can make some connections of what you already know about rates of change, that if it's negative, the function is decreasing, which is what we kind of saw, and if it's positive, that the function is increasing, which is also something that we can at least surmise from this table of values.